Hi, my name is Renato. I am a developer advocate at Dashbird. Welcome back to our well-architected tech talks. Today's topic is the serverless trilemma. Before we dive into it, we'll be posting lots of content on well-architected and all things serverless, so to stay tuned, go to dashbird.io/subscribe and make sure you will not miss the next one. So the serverless trilemma framework was developed a couple of years ago by a team of researchers in IBM. It helps us evaluate architectural designs and make decisions considering the trade-offs involved. The framework constraints are black box, double billing, and substitution. We will dive into a little bit more details about each one next. So the black box principle indicates that each function should work independently from the rest of the system and no implementation details should be leaked. So as an example, consider two functions running on AWS Lambda, A and B. Function A uses the AWS SDK to invoke function B and request something from it. So far so good, but what happens if we need to move function B code to another infrastructure? Perhaps the AWS memory limits is not enough anymore for the function to run. Now the AWS SDK invocation process will not work anymore because it's not aware of where the function was moved to. So this type of architecture makes it difficult to introduce changes and increases the likelihood of unintended consequences as the system grows. Function B is leaking its implementation details, so it's not working as a black box. That's the problem here. So the leakage is having function A aware that function B is deployed in AWS Lambda. To satisfy the black box principle, we could create an HTTP API, a REST API, and by routing requests through this API, we can decouple the two functions. Later, we can just update the API routing to the new infrastructure, and this can be extremely valuable as the system and the development team grows. The double billing principle is relatively simple, so two functions should not run at the same time while one is waiting in an idle state for the other to respond. So in serverless, we pay for the function execution time. If function A starts processing and being charged, then it invokes function B and waits for a response. And while function B was processing, A continued to be charged despite being idle. So once B finishes processing is that A can resume its work. Function B processing time is effectively being charged twice, hence the name double billing. Ideally, we should avoid such situations. So substitution, the third principle, is about having a composition of functions behaving just like any normal function. So what is a composition in the first place? Consider a user requests an invoice from a billing system. He may rely on a second function to apply any discounts available for this user, for example, and yet another function is responsible for calculating sales tax. So all functions are composed to work as a group, hence the name composition. The substitution principle indicates that all three functions together should behave like a function. So from invocation methods to timeout to dead $Q, everything behaves as if they were a single function. The requester doesn't actually know this is a composition. Any developer can rely on this composition of functions without worrying about how it behaves. They just apply everything they already know about serverless and AWS Lambda functions, for example. And this property is very important because it improves productivity and quality in the overall system. Most of the time, it is not possible to have all properties together, so there is a trade-off involved. Applying the black box principle, for example, is usually easy, but when it comes to the other two, there's usually some trade-offs involved. When we prioritize substitution, for example, we need to sacrifice double billing. So this framework helps to make architectural decisions and identify what needs to be prioritized. The black box improves maintainability, scalability, and resilience by decoupling components. Double billing enables cost efficiency and reduces the concurrency level. Substitution enables code reusability and improves quality. So what should be prioritized will really depend on each case. We will dive into more details about this decision-making process in the next videos on the series. So stay tuned, go to dashbird.io/subscribe and make sure you will not miss the next videos. Thank you very much, bye bye.